Hello students, in this video we're going to preview Quiz 10. Quiz 10 has 5 questions, so it gives you 1 question of wiggle room to get your 4 correct responses that you need for a perfect score. Question 1 is asking you about quadratic inequalities. So we start with a function g of x and we want to find all of the x values where g of x is greater than 0. So we're going to set our function greater than 0, and remember you have to find your critical points, or your critical numbers. And you also need to find your asymptotes in a problem like this, but asymptotes come from denominators, and g of x doesn't happen to have any denominators, so we can kind of forget about that. So once you have your critical numbers, you're going to set up a number line, and you're going to divide your number line into intervals according to your critical numbers, and then you're going to pick a test point from each interval, plug it in, see if it works. If that interval works, or the test point from that interval works, then that interval will be part of your answer. We always write our solution in interval notation. So it might be like, things like this with unions in between or something like that. So make sure you're using interval notation for your answer. For number 2, we're talking about average rate of change, and there are a few ways we can approach average rate of change. Remember that the average rate of change is just the slope between 2 points. So in problem A, we want to use the graph, which means we're just trying to find the slope between point A and point B. That should be pretty easy to do just looking at the line. We can use rise over run. Then for part B, we want to algebraically verify our answer. So you have to show your work on this one. To algebraically verify your answer, you're going to need to remember the average rate of change formula. That will be f of b minus f of a all over b minus a, where a here and b here are x values. So these are for the points x equals b and x equals a. So you're going to need to figure out what the 2 x values are from the points big A and big B. Plug those in to your function, simplify. And finally for part C, once you've done A, this one should be pretty easy. We're just writing the equation for the secant line. Now this is just a line, right? So we need to know the slope, which you'll get from part A, and you need to know the y-intercept, which you can get from looking at the graph, and you just write that as the equation of a line. For number 3, we're dealing with a rational equation, and we've got a few questions to answer about this. We're going to be finding our intercepts. To find your x-intercepts, you let y equal 0 and solve for x. To find your y-intercepts, you let x equal 0 and solve for y. Next, we want to find vertical asymptotes. Vertical asymptotes occur whenever our denominator equals 0. So set your denominator equal to 0 and solve for x, and asymptotes are always lines. So your answer should be written in the form of a vertical line, which should be x equals something. And if you have more than one answer, you can just write them out like this. For part C, we want to first look for horizontal asymptotes. That's where you compare your biggest exponent on top to your biggest exponent on the bottom. If the top exponent is bigger, then there's no horizontal asymptote. If your bottom exponent is bigger, then you will have an asymptote, and you'll need to look back in your notes to figure out what that is. And if your top exponent and your bottom exponent are equal, then you will have an asymptote, and you'll need to look back at your notes to figure out what that is too. If there are no horizontal asymptotes, then we need to look for oblique asymptotes, and that happens when your top exponent is 1 bigger than your bottom exponent. And in order to figure out what our oblique asymptote is, we actually have to do polynomial long division, or you could do synthetic division. But either way, we're going to have to divide. And your remainder is ignored, and you just take the answer once you divide. All right. For part D, we're looking for domain. That's our set of all x values. And your domain should very closely align with your vertical asymptote. These two things are closely connected to each other. So use them both as reference for each other. Make sure that these match up. Finally, you're going to use everything we learned from parts A through D to draw this. So make sure you mark your intercepts, make sure you mark your asymptotes, make sure your domain matches up, and if you need to get a clearer image of this graph, you can also maybe find a few points, pick some x values, plug them in to find some y values to make sure that everything you're drawing matches up with our function. For number 4, we're given a graph, and we're just going to answer a few questions about the graph based primarily on the picture. So when we're looking for whether our graph is odd, even, or neither, we're looking for symmetry of some kind. Remember, odd functions are symmetrical around the origin. So imagine if you had a piece of paper with your graph on it. If you rotated this picture upside down, so 180 degrees, you rotated it flat on the surface of your desk, you just rotated it around 180 degrees, it would look the same. That's odd. Even, on the other hand, is if you have your graph in the middle of the page and you folded the page in half. So you folded it over on top of each other. Would the two sides match up? That would be even. And if it's neither of those things, then you're neither. Local mins and local maxes are places on your graph where you're going down and then you turn and go up at some point. And for maxes, it's the opposite. You're going up, but then you turn and go down at some point. So they don't have to be the very lowest point on your graph or the very highest point on your graph. You know, your graph can go up even higher than that. But as long as in that small space, it's the highest point compared to the other points around it, it would be a local max. And vice versa for a local min. So we're just looking for those points. And you want to write your answer as a point, so x comma y for these. And you might have more than one answer for each of these. Just separate your answers by commas. The x-intercepts and the y-intercepts are the places where our graph crosses the x-axis or crosses the y-axis, respectively. And for end behavior, we're just looking for basically arrows. And I think we were told at some point that if your graph ever goes off the edge of the page or the edge of the graph, you can assume that there are arrows there. So look as we go further and further to the left is y going up or down. And as we go further and further to the right is y going up or down. That will give you your positive infinity or your negative infinity. Now finally for number 6, we're doing an inequality. We're looking to see where our graph is less than or equal to 0. That means we're looking for the places on the graph where our graph is below or on the x-axis. And our answer is going to be an interval, but an interval of what? We're looking for the x intervals that make this happen. So the set of all x values for which this is true. But you'll write your answer in interval notation. So that's the one where we've got parentheses or brackets with unions, that sort of thing. Okay, and our final question. This one is using or asking you to use the factor theorem. I recorded a short, maybe 10-15 minute video about the factor theorem. It's just kind of a blip at the end of one of the other videos. And we only did one example about this in class because it was the only example on the common homework. So I do want to take this opportunity to just kind of remind you what the factor theorem says. If we have x minus a as a factor of f of x, then f of positive a should be equal to 0. Let me break that down. If x minus a is a factor of f of x, that means that a is a root of f of x. If a is a root of f of x, then when we plug it into our function, we should get 0. So what you're going to do is you're going to take this number, you're going to switch its sign, and you're going to plug it into your function. If you get 0, then it is a factor. So when we're dealing with just a simple x minus 2, it's pretty easy to see how this is going to work. But the second example, the second thing you have to test is a bit more complicated. We don't have just an x minus a. Here we have a 4x minus 5. So what you'll be plugging in here is what would be the, quote, root, which would be positive 5 over 4. Imagine if we had 4x minus 5 equals 0. What would make this equal 0? Well, you'd add 5 to both sides. You'd divide both sides by 4, 5/4. So if this were a factor, then its root would be 5/4. So that's what we're going to be plugging in and seeing if that's equal to 0. If it is equal to 0, this is a factor. If it's not equal to 0, it's not a factor. So that's kind of the process that you'll follow on these questions. Now, normally I don't like to go into so much detail on a quiz review or a quiz preview, but since we didn't get to cover this very thoroughly in the other videos, I just wanted to make sure that I explained this to you before the quiz. So that's it. Best of luck. Please, please, please try to get your quiz turned in by the feedback deadline. That way I can help you fix any mistakes that you might have made, and it will improve your chances of getting a perfect score on the quiz. Good luck, and let me know if you have any questions.